Today's lesson is applying exponent properties with rational numbers. So take a look at the warm-up problems. These problems should help you review all the exponent properties that you learned in your Algebra 1 class. Number 1, when you're multiplying the same base, you're simply going to add the exponents. Answer is 4 to the 11th power. Number 2, you're going to subtract your exponents because the base is the same in this division problem. Number 3, you're going to simplify your radical. You would have learned this skill in Algebra 1 and would have had to have used it again in geometry. You want to rewrite 48 as a multiplication problem where at least one of the factors is a perfect square. On number 4, you'll want to merge those two radicals together and multiply 30 and 15 underneath the same radical. And then you can simplify it in the same way you simplified number 3. Number 5, you'll also need to simplify each radical, and then in essence you'll have like terms and you'll be able to subtract them. We'll see more examples of this with rational exponents coming up in just a little bit. To recap yesterday's lesson, just a quick example that shows you a possible situation where you might need to use exponents. In this case, if you knew this fish's weight, but you really needed to know the length, you could put 200 in place of W, divide both sides by that coefficient, and then cube root both sides. And you could say that the length of that coral codfish was approximately 23 centimeters long. Once again from yesterday, we need to get used to seeing that the fifth root of a number is what you get when you take a different number to the fifth power. We need to see the relationship there. The fifth root of 32 is 2, and 2 to the fifth is 32. I'm able to make that connection. As we look at simplifying expressions today using rational exponents and also using radicals, you'll see that many formulas in science will use exponents like this. When you're calculating the velocity of a jet, when you're finding a star's magnitude, that's its brightness in comparison to other stars. Apparent magnitude of a star can be used to help you calculate the distance the star is from the Earth and other things. Formulas also will help you find maximum horizontal distance of a projectile launched. For example, when you hit your golf ball, will it land on the green? When you launch your grenade, will it hit what you want it to hit? Will it have that horizontal distance you're looking for? So, quick recap of the exponent properties you had in your Algebra 1 year, but in Algebra 2, your exponents will be fractions. They'll be rational numbers, but the properties still are the same. So you might want to pause and list the properties. Now notice we didn't even list the properties' names. We need you to recognize how the properties work and why they work that way so you can apply them later on. So pause and make sure you put each of these 6 properties in your notebook. Let's see how they'll be used. When you have an exponent outside of parentheses, typically you would distribute it to each term inside the parenthesis, but this is a negative exponent. So in this case, let's apply the negative exponent property first. That means everything that's being taken to a negative exponent will go down in the denominator, and the exponent now becomes positive. Now we should distribute our exponent. So we'll have 4 to the 5th, and that's being raised to the 1/5 power. 3 to the 5th, and that's being raised to the 1/5 power. When you have a power to a power, as you do with the 3 and the 4, each of those terms, you will multiply your two exponents together. So that 4 to the 5th raised to the 1/5 becomes plain old 4. 3 to the 5th to the 1/5 becomes 3. Now you can simplify your denominator, and your final answer is 1/12. The next example is where you will subtract your exponents, in this case of the division problem. So the numerator's exponent, 5, or the numerator's term of 5 has an exponent of 1. So we will take 5 to the 1 minus 1/3. Simplify and you'll get 5 to the 2/3 power. Again, rational exponents are used in a lot of formulas, a lot of times in the science field. So here's an example that you can calculate a mammal's surface area. In this case, they asked us to find the surface area of a rabbit. Substitute the information in. When we distribute that 2/3, the 10 to the third raised to the 2/3 power becomes 10 squared. You'll have to take 3.4 to the 2/3 power. It becomes pretty much a calculator activity. A couple of additional properties to put into your notebook. You had these properties in Algebra 1, but at that time we were only dealing with square roots. Now you can have any root, a third root, in other words, a cube root, a fourth root, a fifth root, but the properties still work exactly like what you learned in your Algebra 1 class. So as you look at this top example above the purple line, when you have a multiplication problem, and each one is a cube root, you can merge those two numbers underneath the same radical. Multiply them together, and you'll recognize that, oh, you have a perfect cube. When you have a division problem, you can merge both those numbers underneath the same radical, only because they were both cube roots. If the numerator had been a fifth root and the denominator a cube root, it would not have worked. But because they're both the same root, you can merge them together. I would then reduce that fraction to 27 and take a cube root of 27, which is 3. Other examples, and this is similar to the last warm-up question, you can almost view this one as a very basic algebra problem where you're combining like terms. You could view this as a 2x plus a 7x. What's 2 plus 7? 9. So you're going to have 9 times the sixth root of 3. Final two examples. You want to simplify what's underneath this radical. What's underneath your radical is you have a multiplication problem. So let's give each factor, the 64 and the y to the 6, its own radical. When you simplify the cube root of 64, you'll get 4. But to simplify the y to the 6th, you want to be able to write 6 using the number 3 because you're cube rooting. If you can rewrite y to the 6th, instead of using a 6 but using a 3, you can further simplify it. And that's indeed what we did here. This power to a power, this y squared raised to the third power, that's the same thing as y to the 6th. And then you'll see that this cube root and the cubing cancel each other out. So the net result of simplifying the cube root of y to the 6th is changing it to cube root of y squared raised to the third power. So this the cube rooting and that cubing cancel each other out, and you're left with y squared for a final answer of 4y squared. Very similar idea with number 2. Give the numerator its own radical, the denominator its own radical. The numerator, you have a fourth root of m to the fourth, and once again, that fourth root and that fourth power cancel each other out. Your numerator will become m. The denominator, though, we want to be a little more careful with and rewrite 8 using 4. What's 8 using 4? 2 times 4. And just like in the numerator, we have that fourth root and the 4 that will cancel each other out. And the denominator, when we simplify it, is n squared for a final answer of m over n squared.